Well, please welcome Heather Morrison.
Check out my clicker. Okay. Bonjour tout le monde. Hello, everyone. As Kara said, my name is Heather Morrison. I'm the Executive Director of the Canadian Centre for Climate Services at Environment and Climate Change Canada. And before I begin my talk today, I would like to take a moment to acknowledge the land on which I stand as the traditional territory of many First Nations, including the Nihoyo, the Dene, the Nakota Sioux, the Niitsitapi, and the Anishinaabe. I would also like to acknowledge that the city of Edmonton is on Treaty 6 territory, within Treaty 6 territory, to be clear, and within the Métis homelands and the Métis Nation of Alberta Region 4. I come to you today from the city of Toronto, which is also the home of many First Nations. And I just want to communicate my respect for the land. I have devoted my entire professional career and a good chunk of my personal career to my personal life, which sometimes feels like a career, to environmental conservation and preservation. And so I am very pleased to be speaking to you today to a group of people who are equally committed to creating a sustainable future for our children and our children's children, as we've spoken to earlier today. So with that, I'm going to talk to you about climate change in the prairie provinces. I know there are mountains, so call it an Easterner thing, but I'm so used to calling Manitoba, Alberta, and Saskatchewan the prairie provinces. My husband comes from Saskatchewan, so I do have a bit of grounding in the prairies and maybe a bit of a bias to that effect as well. I'm going to speak to you today about the Western scientific observations of change that we have seen to date in the physical climate and our projections of what we expect to see in the future. So with that, I'm going to begin by just grounding this presentation on Manitoba, Saskatchewan, and Alberta in the change we have observed globally to date. So what you see on the right are the change in the global mean temperature between 1850 and 2018. And as you can see, the temperature globally has increased, no surprise to anyone in this room. That increase in temperature is unequivocally the result of human-caused greenhouse gas emissions, which we also refer to as anthropogenic greenhouse gas emissions. If you superimpose the latter half of that global trend onto the graph on the right, you will see the global trend in mean temperature change in red and the mean temperature change we've seen in Canada over that time period in blue and in the Canadian Arctic in gray. And what you can see is that the rate of temperature increase in Canada has been approximately twice the rate of global climate change, and about 3 times the rate in the Canadian Arctic. There are a number of reasons for this, not the least of which is just where Canada is situated on the planet Earth. So the next slide, which will kind of set the context for the talk, is on reaching net zero. And really this slide is a really good reinforcement for why it is very prudent for all of you to be here talking about adaptation. So the graph on the right is an experiment that was run by Environment and Climate Change Canada in 2020 and published in 2021 in Nature Climate Change. It's an experiment that's been repeated many, many times by other climate modeling centers around the world. And what you see in that graph is in black, the global temperature change that is projected under a business as usual scenario where we continue to emit greenhouse gases essentially unabated. What you see in green is what happens when all of human greenhouse gas emissions are turned off. So if we turned off all greenhouse gas emissions from anthropogenic sources in 2010, what you see is what would happen to the global temperature. If we turn those emissions off in 2100, which is the graph, which is the red line on the graph, that is what will happen to global temperatures when we turn off all greenhouse gas emissions in 2100. I drew the line in yellow in the middle at 2050 because that's the Paris Agreement date. So just for reference. So what this graph illustrates, what this study is telling us, is that the warming will not stop until anthropogenic greenhouse gas emissions reach net zero. As long as there are emissions, the warming will continue. It will not stop. When we stop emitting greenhouse gases into the atmosphere, the planet will not cool off. It will stabilize at wherever we are at when greenhouse gas emissions hit net zero. So if you wonder why we go on and on and on about net zero, this is why we go on and on about net zero, because the warming does not stop until we hit net zero. And when it stops, we will be in a climate regime that we have never seen before. We will never go back. We're not ever going back. So adaptation is a very prudent thing to think about because we will need to adapt because we are never going back to a place we were before. And we're not sure where we're going to end up because we have not reached net zero greenhouse gas emissions. So that's really the key take-home message here, is that mitigation is very important for obvious reasons, and adaptation is going to be equally important because we haven't been that effective yet at mitigating. So now about the prairies. So the climate has been changing, and I'm going to talk about the observations to date. So we're not looking forward yet. We are strictly talking about what we have seen so far. So what we have seen so far in Canada, and this is these maps show the change in temperature in Canada between 1948 and 2016. So what we have seen is that warming has essentially been ubiquitous across the country, but the rate of warming is very heterogeneous in space and in time. So there are some parts of Canada that are warming faster than other places. There are some seasons that are warming more quickly than other seasons. This, again, is a lot of this has to do with just where that land is situated in the context of the global system. So in Canada, the Pacific Northwest is warming especially rapidly, and that accelerated warming you can see goes right down into the Great Plains. So the region that you live in is one of the most rapidly warming parts of Canada, and this is particularly the case in the winter. Precipitation change is equally heterogeneous, maybe even a bit more heterogeneous than temperature. So what we have here is observations of precipitation in southern Canada from 1900 to 2019, so 120 years of data. We're only showing southern Canada because that's the longest data set we have. And then the next slide, I'll show you a shorter data set that includes northern Canada. But it does include Manitoba, Saskatchewan, and Alberta. And what you can see is while overall in Canada, there has been an increase in precipitation, this is very consistent with a warming climate with what you would expect. That has not been the case necessarily for Manitoba, Saskatchewan, and Alberta. There are large swaths of those provinces that have seen either no real change in precipitation over this period of time or have seen a significant decline in precipitation over this period. When we parse this data out, these trends out by season, we can see much more directionality and how precipitation has changed in the Prairie provinces. And what you can see in these slides is that precipitation, so now we're looking at trends from 1948 to 2019, that precipitation has declined significantly in the winter in over much of the Prairies. It's been kind of a mixed bag depending on where you live in the spring and in the summer. And there has been largely an increase in precipitation in the autumn. So what I want you to take out of this slide, because it'll tie into a story on the next slide, is that in the Prairies, precipitation has declined significantly in the winter. But in the autumn, there's generally been an increase in precipitation. So why that is important is because in the next slide, I'm going to talk about snow. Snow is something that's very important in the hydrological cycle. It's important for farming. It's important for hydro production and for other reasons. And so snowfall plays a significant role in really sustaining a lot of the water-dependent production in these provinces, in Manitoba, Saskatchewan, and Alberta. And what we can see is that in the Prairies, in the relatively recent past, so one data set we have for snow accumulation is 40 years. The other data set we have is 70 years. What we've seen is generally an increase in the accumulation of snow over the snow season, which sadly for many Canadians starts in September and goes to the end of March. So you may be saying to yourself, well, how on earth could that be? Because you have just told us that the precipitation in the winter is declining, and now you're telling us that snow accumulation has been greater in the last 40 to 70 years. So why that is, because we've looked at this, fortunately, is if you look at the small maps of Canada at the bottom, the one on the left is the change in temperature in the autumn over the period of 1955 to 2023. On the right, it's the same map, change in temperature in the autumn for 1981 to 2023. What you can see is that the temperature in the autumn in this region has not really changed that much. It's warmed a bit, but not a lot. So what that translates to is that although it's gotten a bit warmer, it's still cold enough that precipitation that's falling in the autumn can fall as snow. And in fact, when we look at snow accumulation in the autumn, which is the little map of Canada beside on the right-hand side at the bottom, you can see that there's in most regions and most parts of the Prairies, there's an increase in snow accumulation in the fall. And that snow accumulation in the fall is persisting over the winter, and it is essentially masking the decline in precipitation that you are seeing in the winter. But Lawrence Mundrick, who did this study, told me emphatically to tell you to not expect this to continue. So in a way, you've gotten lucky, you've been buffered, you may be buffered for a little bit longer, but eventually it will warm enough that that precipitation in the fall is not going to fall as snow, and it is not going to persist over the winter. And so you're not going to get that freshet of snow in the spring that so many people count on. So that little words of advice from Lawrence is a nice segue into the second part of my talk that talks about what we expect to see in this region going forward. So I didn't bother to put up a slide that talked about how it's going to get warmer, because trust me, that is a given. But what I did decide to do was put up a slide that talked about humidex. So if you have ever spent time in Windsor, Ontario in the summer, which I did for 3 years when I was doing my degree, or Toronto or Montreal for that matter, you know that summers, they're not just hot, they are very humid, and it is super uncomfortable. And it really does drain your energy for really being productive in an outdoor environment. So Environment Canada recognized a long time ago that the way people experience heat is much different when it's hot and humid. So they developed an index called the humidex, and the humidex describes how hot the weather feels to the average person by combining heat and humidity. And many regions that face a lot of hot and humid weather, they have developed occupational health and safety standards, public health mitigation measures that all kick in when the humidex increases above 30 degrees. I'm not sure why that is up there. Now, many parts of the prairies have never experienced humidex. So that's the reason why I put this slide up here. And we have done some work at the Canadian Centre for Climate Change, for Climate Services, where we have projected the change in humidex across Canada under different emission scenarios. And what this slide tells you is that many parts of the prairies are going to experience a significant uptick in the number of days where the humidex exceeds 30. So if you work in public health, this is when you need to start thinking about cooling centers. If you're in occupational health and safety, you need to think about measures to protect outdoor workers. You need to think about HVAC systems in buildings, particularly buildings that house older people. So that is something that in this region, you may not have had to think about in the past, but you're going to have to start thinking about in the future. So the other thing that you're thinking about already is drought. And so Environment Canada did a study. Almost all of this research is done by the Climate Research Division at Environment Canada. So they did a study where they projected the future annual standardized precipitation evapotranspiration index for Canada under different emission scenarios. So what this is it's an indice of drought. And when that index is below -1.5, that denotes severe drought conditions. So what they did is they forecasted how many years in a 20-year period at the end of this century will Canada be under severe drought conditions. And what they found is under a low emission scenario, you can expect up to 4 years out of 20 to be under severe drought conditions in the southern prairies. And under a high emission scenario, you can expect as many as 12 years out of 20 being under severe drought conditions. So basically, that's a lot of drought, really, to just cut to the chase. So drought and wind combine to create conditions that are very conducive to wildfires, something that we're all very cognizant of as well, because wildfire incident has increased the frequency and severity with our changing climate already. And so at the Canadian Centre for Climate Services, we also projected fire weather indices, which is a number that is used in the models that forestry services use to project forest fire risk. It's the meteorological component of those forest fire risk models. So we projected how that would change under different emission scenarios. And basically, by mid-century, under a high emission scenario, the length of the forest fire season in this region will increase by up to a month, longer than what it was in 1971 to 2020, which was the base year. So climate change acts in two ways. One, it causes gradual insidious changes to the environment, things like temperature, precipitation. It also increases the frequency and the severity of extreme weather events. So an indicator of how extreme weather events have changed in Canada is illustrated in this graph from the Insurance Bureau of Canada, which probably many of you have seen before. And it is a graph of the insured catastrophic losses in Canada from 1983 to 2020. I think I'm up to 2002. And what I've done is indicated which of those major insured catastrophic loss events can be attributed to a severe weather event. And as you can see, the biggest bars are all attributable to a severe weather event. The biggest one there was Fort McMurray in 2016. And Environment and Climate Change Canada did an attribution study on that. And what that means is they looked at how climate change had impacted the frequency and intensity of the conditions that led to the Fort McMurray forest fire. And climate change made that forest fire 1.6 to 6 times more likely to occur. And they've done more work looking at how those incidents of events like that will change in the future. And obviously the news was not good, that those events will become much more frequent in the future. So we've done, Environment Canada has just developed essentially what they call a rapid event attribution system. So a system that can basically discern how climate change has contributed to an extreme event within a matter of days. And there's a whole bunch of reasons for doing this. One is just for communication. So when we're talking about the weather, we can tie in a climate change story to that. But the more useful reason for doing it is that that system can also tell us how much more frequently that type of event will occur in the future under different emission scenarios. So I have time to talk about one of these studies here. So I decided to talk about the heat wave in Alberta in May 2023. And I don't know how many of you remember that event. I don't live in Alberta, but I remember that event. It was a really severe heat wave. And it was actually, as you can see from the graph, it was like a succession of heat waves. But the first part of it, which started on April 30th, led to the highest recorded temperature, I think on record, if I recall correctly. And that temperature was recorded on May 4th. So Environment Canada did a study to look at how climate change had contributed to that extreme event. And what they found is that climate change had made that event like 3 times more likely than it would have occurred in the absence of climate change. But really, most importantly, in terms of planning, that heat wave event that happened on May 4th, which was at the time a 1 in 100 year event, will be a 1 in 4 year event by the end of the century under a moderate emissions scenario. So if you were hot on May 4th, if you managed to live to the end of the century, be prepared to have that be a regular event. And just to explain a little bit what's on the graph on the right. So for these attribution studies, what they have done is they've looked at the distribution of maximum temperature in Alberta for the month of May in conditions where there was like massive climate change, so from 1850 to 1900. So that's the distribution of temperature in the green. Then they compare that to the distribution of the maximum temperature in the month of May in Alberta under present day conditions. So that is, I'm trying to read my slide, which is very far away, but I think it's 2012. Somebody correct me if they can see it better, to 2032. So that's the distribution of maximum temperature. And then they compare that to the distribution of maximum temperature in the month of May in Alberta under a moderate emissions scenario at the end of the century. So that's the blue curve. And what they've done is, well, what I did is I just drew a line where the May 4th temperature was, and where the red line intersects the green curves. If you trace that to the left, that tells you the probability of that temperature occurring. And as you can see in the future, there's a lot more blue on the right side of the red line, which means that that event, which will be a 1 in 4 year event, will also have friends that are 1 in 10 year events, and there'll be temperatures that are 1 in 100 year events. So it gives you an indication of what you need to plan for. So I presented a ton of Western data to you. Tried to do it quickly. But you might be thinking, well, this is all interesting, maybe, hopefully, but I'm probably going to forget tomorrow. And really, if I ever wanted to find this data, where on earth would I find it? So what I'm here to tell you is you can find this data on climatedata.ca. Climatedata.ca has most of the data sets I've talked about. Some of the data sets that I've talked about will be on climatedata.ca in the next few months, like fire weather index. Some will be put up in the next year, like snowfall. The results of the attribution studies in a couple of years, we will make essentially a catalog of those studies available on climatedata.ca. But you may be thinking, great, so I get the data, I do the data, but I design storm sewers and I don't know what to do with this climate data. I'm a storm sewer engineer, where would that fit? Or I design HVAC systems for apartment buildings, and honestly, I don't know how I'd use it. Yes, it's getting warmer, but really when I'm doing my energy models, I'm not sure how this works. Or I'm a farmer and I want to plan for the future, but really I also don't understand how to use this data. So no shame there, as this is really extremely difficult data to work with. But the good news is that we have all kinds of services that are free that are here to help you use this data in your context, in the decision-making frameworks that you use. So these services are called climate services. We have climate services aimed to equip decision makers, be they engineers, farmers, municipal planners, public health, to integrate climate information into their planning and decision-making and risk assessment frameworks. And that is because we recognize that decision makers need climate information in a way that suits them and their needs. So in Canada, we have the Canadian Centre for Climate Services. We are here to help you. You can call us. We have a 1-800 number, email us. We have a website. We are always here to help. However, we recognize that most adaptation decisions are inherently local and they're very bespoke, and they really benefit from local knowledge, information, networks, examples. So in recognition of the fact that there's a lot of Canadians that will need climate services and that they really benefit from local information, the federal government has worked with the provinces and territories to develop a network of regional climate service providers. This is what the network looks like in Canada. And of course, the regional climate service provider that is here to serve you is ClimateWest. So if you feel that you want to incorporate this information into your work, into your planning, into your risk assessment process, but you have no idea where to start, there is help for you. It is free, and we are more than happy to work with you. And I can say on the federal side, we work with everyone. We work with small little businesses to huge risk assessments for the Department of Defense, for we work with provinces to do huge infrastructure risk assessments. So from big to small, we are here to help, and ClimateWest is really your first go-to. So with that, I'm done, Kara. I will just give a summary. The slides here, that the climate in the prairies is changing, and this includes changing risks associated with impactful extreme events. Only when we reach net zero global greenhouse gas emissions will the warming stop. So you might hate the message, you might hate the carbon tax, you might hate this, you might hate that. But I hate to tell you, we have to stop emitting greenhouse gases. There's just no way to get around that. If we want the warming to stop. If you want the warming to continue, we're on a great path for that. Climate services are available in Canada to support climate smart decision-making and resilient infrastructure design. And adapting to climate change means planning for a future that will have increased risks due to extreme events and the other gradual changes that are occurring. So thank you. Thank you. Okay. You can use this mic.
So that was a lot. I do want to take 5 minutes to answer questions, or like, you can
Sure.
take a few questions, and we know we won't get to them all, and we want to go to a break because it was so much. I think
Yeah.
people probably need a break. So 5 minutes. If anyone has questions for Heather, feel free to ask at the mic or pop them into the Mentimeter. And if we can't get to them all, we can endeavor to answer the questions afterwards and email that out. So any questions, given all of that on the data or on the key messages? Okay, here we go. Okay. Position appeared to be backing away. Okay,
Yeah, that one.
it's about urgency.
Yeah.
And the message you deliver to us is urgent, right? That there's urgent action required. I know I struggle with this daily. And now that I'm working in this field, it helps a lot because I can like put my energy into it. But we need to do it right, is my opinion. We need to work and take actions, with each other and build that time in for collaboration. Did you have anything you wanted to say in terms of like how you feel on the sense of urgency, or like this message when you're delivering it? Is this the kind of question that you get from people sometimes on like, what do we do now that we have all of this data, and are people paying attention to this data?
So I will not lie. In my position, I mostly speak to the converted. The odd time I end up speaking to someone who's not part of the converted, which is shocking for me when I am totally surrounded by people who are converted. But I really think it comes down to this. Like, from my perspective, it's really hard to ignore the fact that the climate is changing. So one thing about adaptation is, in the adaptation world, we're not, which makes it much easier than mitigation, we're not telling you to like fundamentally change the underpinning of our economy. We're basically telling you things are going to change. It's a good idea for you to assess how those changes might impact your sustainability and that of your business. And if you want, we can help you think about how that might interface with what you're doing so that you can plan to be more resilient. So in the field I'm in now, it's usually a much easier conversation, because you don't need to believe it, and you don't need to pay attention to it on the adaptation side. But then you're taking the risk that you will be less resilient when these changes come. And what we're hoping, mainly because for provinces and for federal government, we are an insurance backstop for when you are not prepared. It is very like, we are sending this message out to you, because if you decide not to prepare for the change and then you are impacted by the change, there is a cost to that. There will be a cost to you, but increasingly there's a cost to the provincial government and the federal government that then has to backstop a lot of that destruction and intervention. So in that regard, it's kind of a neutral about it.
Thank you for that. And last year's conference was all about the cost of climate change. And so the message kept coming out about like, invest now in adaptation and get prepared, because it's going to be more expensive if you wait. Let's take Andre's question and then we'll go to break.
Great. Thank you very much for your presentation. I appreciate it. I wanted to ask a bit about your early statement about if we hit net zero, that's where it stays, the temperature stays. I'm just wondering, I'd heard or had read some studies that say that some contributors of greenhouse gases have different lag times, like some of it's already baked in, if that makes any sense. And just wondering if it is baked in, could we start pulling it out of the air and make bricks out of it or something? And will that impact anything?
Yes. So as you can see by the graphs, there's not a lot that is baked in, less than I think they originally thought. Because as you saw from that study, which was an idealistic study, because they projected climate change and then they literally just turned everything off in the model. So it's as clean as you can get. But there wasn't really a huge lag in when the atmosphere responded. It basically, started to move into an equilibrium. That equilibrium is with the oceans, because the oceans have absorbed a tremendous amount of CO2. That's why we haven't warmed quicker. But as soon as we stop emitting CO2 into the atmosphere, the ocean now is going to come into basically a chemical equilibrium with the atmosphere, which will hold the temperature for thousands of years, because we have emitted so much CO2 into the atmosphere. I mean, if you think about every barrel of oil and you think about Einstein, who proved to us that you cannot make mass evaporate. So every physical barrel of oil that has ever come out of the bottom of the earth is now sitting in the atmosphere or the ocean. So, basically, the good news is, I guess, there isn't a huge lag when you go that cut cold turkey. The bad news is that we've reintroduced so much CO2 back into the biosphere that we will have to get used to living with it for a very long time.
And what a message that is.